The reactor experiment facility, designed by Atomic International, was situated in the northwest administrative section known as Area 4 of the Santa Susana Field Laboratory, about 30 miles or 48 kilometers northwest of downtown Los Angeles in Simi Valley. It was known as the Sodium Reactor Experiment, or SRE.
As the threatening residues clogged the reactor's internal cooling channels, 13 of the reactor's 43 fuel elements overheated and were damaged occurred between July 12 and 26 in 1959. At the time, operators were aware of unusual reactor behavior but were unaware of the damage. They continued operation for several days before shutting down the reactor for examination.
It's been reported to have released up to 240 times more radiation than the 1979 disaster, which is 3 Mile Islands, because the experimental reactor did not have a concrete containment structure.
In 1961, the Atomic Energy Commission made this film, which documents the extent of the damage and cleanup process. It also explained exactly what went wrong inside this unique reactor, where molten or liquid sodium was used instead of water to remove heat from the swimming pool-sized reactor area. Because water couldn't be near the reactor, a chemical known as tetralin was used to cool the bearings in the pumps that circulated the sodium as it carried heat away from the fuel rods. Everything worked well until tetralin started leaking through cracks in the pump seals and into the reactor. As the tetralin approached the fuel rods, it partially blocked the bottom of some of the coolant channels. When coolant flow decreased, the heat by those fuel rods increased and eventually reached melting point.
The radioactive byproduct from the reactor operation have to go to the molten sodium, and some byproducts come out as vapor, and in this case, the vapor went to the atmosphere that will affect the surrounding, including workers.
Exposure of Santa Susana Field Laboratory workers to the radiation was associated with an increased mortality rate of individuals suffering of cancers of the blood and limb system and from lung cancer. Effect to the surrounding on human and environment is: first, bladder cancer. Second, trace of the contaminations will remain well into 2019. Third, thyroid cancer in the local area. Then, cancer of the blood and limb system and lung cancer. Lastly, workers that exposed to radiation has triple amount of cancer death rate than those not exposed. Action taken by the Council associated with the accident: first, develop and perform full-scale testing for a wide variety of sodium components. Second, wash cell cleaning process, switch from water to steam. Third, instrumentation was improved and the fuel element geometry was modified. Fourth, the sodium system was modified, and then Department of Energy gave the U.S. Environmental Protection Agency $40 million to complete a radiological survey of Area 4. Then, improve the safety and reliability of sodium pump seals. Next, provide development and non-nuclear testing of liquid metal reactor components. Lastly, the sodium reactor experiment began operation with a new reactor core.
Of the 3 most prevalent radioactive elements identified at the Santa Susana site, cesium-137 has the longest half-life at 30 years. Dangerous amount of it will remain there for about 300 years.